what they want is they want to see what happens at this point, right? So I just want to tell you that basically path difference means how far or sort of how many wavelengths away two waves were or longer if they met at a point, which means generally path difference has a formula of n lambda. Okay.
Yes. Hmm.
Now, you need to remember if at a certain point it is constructive interference, then n should be equal to 0, 1, 2, all whole numbers. Is that clear?
Yes.
And if at any point it basically the waves are in destructive interference, so they're 180-degree phase to each other, then n would be equal to like 0.5, 1.5, 2.5, 3.5, like that. You get my point?
Yes.
Okay. Now, so what really happens is that suppose in this question, if I want to see what happens at this point, so first of all, I'm going to find the path difference. I'm going to say the path difference is equal to 7.0 minus 5.0. So that's the difference in length between these two, which is going to be 2.0 meters, right?
Yes.
Then I'm going to put path difference equals to n lambda. So 2.0 is n lambda. And because the wavelength is 0.2, so n will be 2 divided by 0.2, which comes out to be 10, right?
Yeah.
You see, it's a whole number. Since it's a whole number, then the waves that meet at point P meet constructively. Do you understand?
Yes.
Cool. Now, another question like this. So it says a microwave of wavelength 4.0 times 10 raised to power minus 2 meters interferes within a microwave oven. All right.
Yes.
Microwave oven. Okay. Let's say as shown in the diagram. State after calculation if they meet constructively. So what they've shown is they've shown the source here, hole here, hmm, A, B, C, and I guess. All right. So one basically goes up, touches the ceiling, and then hits onto the pot, and one goes straight. Okay. This is like, okay, wait a second, please. So this is like 2 centimeters. Let's write meters, in fact. 2 meters. Let's take it 10 centimeter. Sorry, 2 and 8. Wait, no, that would not be good. 2 plus 8. I want something like bigger, actually, not this one. 6 meters and 12 meters and 8 meters. Okay, like that. So, Ikra, can you please find the path difference first and see if it's like if it's constructively interfering or not, right? Or destructive. Please go ahead. Take like 2 minutes, please.
Is it constructively?
So, Ikra, what was your path difference?
6.
How? What you do? This is ABC is one path and AC is one path, right? So it should be 6 plus 12, no? 18 minus 8. No? Do you get my point?
How it is?
6, it goes here, like it
Yeah.
goes A, B, C, and then you're subtracting AC. And the other path is AC. You know, reach here, right? That's fine.
Oh,
Do you understand? Like that.
yeah, I get it.
Okay, do it again, please. Yes.
It's 250 now.
It's basically n lambda is 250, right?
Yeah.
Sorry, n lambda is like 10. And what you did n times 0.04. Obviously, your answer is 250, which is constructive interference, right?
Yeah.
Okay. Do you understand now? Like that. If this was in like 250.5, we'd say it's destructive, like that. Okay, done.
Yes.
Now, Ikra, so now let's look at some of the questions from the exam paper. I'm just, putting it up. Hold on. Did I give you a question? Did I give you some questions? Not yet, right?
No.
Okay. Then I'll give you. I just wanted to explain some of the questions, then I'm going to give a worksheet as well. Because we're done with this, and after that, we just need to start with quantum. Hmm. Okay. All right. Now, so for the first one, if you look at this, it says that two coherent um, sources emit waves of wavelength lambda in phase. Okay. At a point where the two
Yeah.
waves meet, they have a phase difference of 90 degrees. Is that clear?
Yeah.
Which of the following could be the path difference at this point? Now think about this, right? So it's pretty easy this way to understand that when you're looking at 90 degrees, so we know that one lambda is equal to 360 degrees, right? You remember this?
Yeah.
So 90 degrees is going to be what?
1/4
A,
lambda.
nine, a quarter lambda, right?
Yeah.
So if they meet the phase difference at a point, emit so they have emit a wave of lambda in phase, right? So they have the wavelength in phase, and when they meet at this point, you might see they have 1/4 lambda. So that should be the answer. Do you understand like that?
Yes.
Yeah. So it's pretty easy that way. Okay. Ikra, all right, Ikra. So in the next question, it says that so on the diagram, mark a point on the water surface whose motion exactly 180 degree with x. Now, if you look at this right now, the wave will actually move somewhat like this, right? Do you understand? So which means that x is going up. We want to find a point which is 180 degree to this. 180 degree means that exactly a point which might be here and it will be going down. Do you understand? Like that. But it should be the same distance, right? Let me check if it is the same distance. So it's basically from the uh, crest, it's 1, 2, 3, and it's also like from the trough, it is 1, 2, 3. So a crest should be here, and it will be going in this direction. So that's 180 phase difference. Do you understand?
Yeah.
Okay. Now Ikra, it says draw an arrow Y, show the direction of water moving the instant shown. Draw. Okay, so now again, if you draw a wave like this, right? So it's going to go up. So definitely Y is going to go down. Do you understand?
Yeah.
And then it says mark a point on the water surface that is at rest. That is at rest at instant shown. So obviously, uh, any max displacement would be at rest, which means you can draw it here or here or here. These all points are at rest, and you can just point B. Is it clear?
Yes.
Yeah. So then I just want to do one question. It says compare the properties of two sound waves necessary to reduce complete cancellation of two waves that reach air. Okay, so this is for destructive interference. You can do this yourself. I'm actually trying to. Okay, for this one, it says a beam of light travels a distance x to arrive at a point. The second beam of light of same frequency initially in phase with the first beam travels at distance y to arrive at the same point. For destructive interference to occur between these two beams, the path difference xy must be equal to, what do you say? When is it like destructive interference?
When the answer is in points.
Yeah, it's odd number. So it's basically answer in the points. Odd number of half length means basically an odd number of half wavelengths mean like 0.5, 1.5, 2.5. Do you understand like that?
Yeah,
That's why it should be this one. And yeah, otherwise any whole number would be the same. Very good. So, okay, so this is a very this is the similar question that I gave you, right? All right. So it says the wavelength of microwave is 12 centimeter. Explain why S is a cold spot, and you need to, do the working. Like you will add like one path is from Ikra from here till here, the other path is from here till here. So you have to add both, subtract them, you'll get a particular
part
wavelength, right?
different.
Path difference, and then you can divide it by the wavelengths, which is 12, and see whether you get like in point, like in half um whole numbers, or you get full whole numbers. Do you understand? And
Yeah,
obviously, if they say why S is a cold spot, so cold spot means that obviously if there is going to be destructive interference, you're going to explain that, okay, at this point, the wave path difference is like half. And this means the destructive interference, which means both waves are 180-degree phase difference and they cancel out each other. All right. So will you be able to do this, Ikra?
yeah,
Okay, can I send this to you so you can start it now?
yeah, sure.
There are a couple of questions, actually, only a few pages. So I think you will be able to do it. And then we can start from tomorrow. I think it would be best that we start with the new chapter.